Bart, for the introduction. So that's my plan, just a presentation. I will present 5 big questions that I have in my work and where I am living in Wallonne, south of Belgium. I will pass through all these questions. So I am engineer from Louvain-la-Neuve in applied mathematics. I work for different businesses, especially in banks with Bart. In fact, I was a colleague of him. And now I'm working for a public transport agency in Wallonne. So I am very passionate in understanding and analyzing the humane factor, and for me mobility is really a humane science and not at all technical science. And my 2 convictions are data science has to support but cannot replace a business strategy in mobility. That's what I don't like in approach of Mobile 21 is they collect data and then they are wondering what will we do with those data. How will you try to convince the political world that you will change anything? So I believe that first you have to go to the political world and ask them what are your questions, what is your vision of landscape planning and mobility, and then try to find data that can support a strategy, a methodology to develop, and especially in the public transport sector where everybody has his opinion about do I need a bus in my town, how many buses. So it's so hard to be very strict on the methodology to build a public transport network. The second point is you need to be creative in the approach, and I hope my presentation will show you how we try to be creative to tackle a lot of problems. And the last point is I work for a public transport company, but this presentation is only my personal opinion. So first, basic stuff is to do current accessibility analysis of an area. This is made with GTFS data. So you, thanks to open data that Peter will talk about, you can do a lot of maps and transform spatial map into time map, travel map. That's already what the other speaker showed. But there are a lot of improvements that we can do. It's aggregate data from one specific time, one specific moment to a long period of time, to analyze one point and to aggregate data to analyze all the points of an area, and finally to analyze one mode, by example the train or the bus, and combine all modes and see how your territory is covered by your public transport network. So, and then you can also compute, and that's what's most interesting, that you cover the most number of inhabitants with your global mobility system. That's one important thing. The second thing is to analyze the current use of a public transport network. So you can analyze the check-ins by hour, by day, weekday or weekends, by line. For me, that's not so interesting because it's only the answer of the people to your offer. So if you put a lot of offer, then you have more check-ins. So that needs to be tackled with cautiously. You see peaks effects, which is in fact the thing which costs the most for public transport companies, because like every network, the dimension of the peak is the dimension of the network capacity. So the ideal situation is to have the more flat occupation in your lines. So that's one first thing you can analyze. The second is the elasticity between the offer and the check-ins. So to see if you change the offer, how people react to the way they check in. So that's the second interesting thing to do. And the last point is to keep the permanent attractivity of the global offer of a public transport network. And the thing that happens a lot that we cut the offer in the non-peak hours because that costs a lot, and there are apparently not many people. But if you want to have an attractive public transport offer, you need to have offer through all days, through all time, and we will see where you put your capacity. That's the question. But that's important to see those data and to be very critics about those data. The third point is also to analyze the current use of public networks. It's just a map and to see the number of checking by stop points. It's also interesting or not, because if you have only one bus a day or a lot of buses, it will change the reaction of the public to the offers attractivity. And also an interesting analysis is to analyze the elasticity. So if you decrease the number of stop points, how the people will react. Do they make another effort to go to catch the bus or the train? That's interesting to analyze. And that's the stop strategy that impact the speed, the global speed of a public transport line. So if you have less stop, you can have a better commercial speed, and for the client it's better things. So there is a trade-off between speed and accessibility of the network through the territory. And so for me, the interesting question is how to build an efficient public transport network. And the first point is not at all data, not at all mobility, it's land planning. Is the first point to do. It's something that's always missing, especially in Belgium. We never planned correctly and smartly the territory, and then we check, oh, we have problems in mobility. But you cannot have an efficient mobility system if your land planning is bad. That's not possible. So that's the first point. It's to go to the political world and ask what is his vision of the territory. It's required to make choices. So the political world will have to tell this city is bigger than this city, and that's choices that are difficult to defend to the citizens or the voters. But that's the first point. Then you have to create links without data. You have to first have a vision of how you would put cities together. You decide to bind metropolis to all cities, but just some cities between them. And that's something that you do just by doing links, not lines, public transport lines, which is different because afterwards you can combine two links and make a public transport lines, 2 or 3 or 4 links. Then comes the third step, which I called global demand analysis, is to check how we can analyze how people from all ages, with all way of moving, are moving on the map. And so I numbered the cities from 1 to 16. And I would like to know how people are moving from one point to another. And this is something we did. It's first collect big data. So there are now companies that sells big data, which are very representative sample. And you don't need specific apps or otherwise, or the things that exist. Then you have a second step is to define what's a move, because someone who is all the day in his car, if you don't define what's the starting point and an ending point, you will never see it stopping. So you have also to define this. And a last point is to tackle the white noise problem, because in the captation of the data, you can have some ping pong between cells of data gathering. So that's important also to tackle. Then the second step is to define the Voronoi polygons, which is the limits of the cells you define if your data has no start or stop. So you need this to define the origin and destination data. Then the third step is to do a mapping between your cells and administrative, coherent, homogeneous limits. So if you have a cell which is on both cities, you have to map correctly your data on the correct cities. And then you have raw data, which are very high, but this is not all the population. So you have to correct the data in origin destinatory matrix based on the number of people using the tool which was used to gather the data. And so you can find interesting data like living places, and these numbers are different than the official figures, official data, and that's very interesting because you can see cities where you have students, where you have, I don't know how you call false post box from people who are making frauds, so you can have some effects that correct the official number of inhabitants in a place, and that's a second point. A third point is you can try to find the number of employees in your area, making some hypotheses, and this is also different from official data, which is never exhaustive of how many people works in an area. So that's also a way to find them, it's with big data. And also events and hobbies places are very hard to find, and so with big data you can find those event and hobbies place and so on. So you have many things to discover. So you have global origin destination matrix. So with my 15 cities I have previously, then you have a matrix with high value, mainly on the diagonal. It means people that are moving from the same cities to the same cities, and also some entrance of the matrix with have higher value in orange in this case, and then other ones with no value. And these matrices are very new in the way we tackle the public transport approach, because now we can really know how people are really moving on a territory which was never really made by the public transport agencies. And so the fourth step is to define service quality. It's logical that for links between two metropolises you have by example, frequencies in weekdays in 50 minutes, in frequency in holiday of 20 minutes, which is in fact the most important frequency for all, because when you are working all the year, even in summer, and the public transport network are often calibrated on the school periods, which is a problem for the workers, because in summer they need to move, and that's something important. Then you define an amplitude, a speed, and you can define objectives between the links. And the fifth step is to analyze the demand and the real check-ins. And so you can see that from 1 to 5, there are a lot of demand, a medium demand, but there are no check-ins. It means there are no offers. So you can improve the service in a 1 to 5 line. Other case is from 7 to 14. You have a good match between the number of check-ins and the real number of people that are moving from 7 to 14. And then you have another example is from 13 to 13. You have a lot of check-ins, but in fact not a lot of people moving. So I propose, if the budget of your company, of a public transport company, is not unlimited, to reduce the quality of the service and to, by example, to put it from 5 to 1 to 5. So you can adapt the way you will create your network based on the global demand, and that's the final step of the methodology. So you have land planning, which is in fact a political vision of a territory. There, data and maps can really help the political world to understand the mobility and also understand the way people are living. And there you can help, but that's really a way of thinking the territory. The second step is to define the links. You can promote one links, or say, by example, for the lane or MEVB lines to come to Brussels is a political choice. In fact, you can promote to come to Brussels or not. So there is a vision at that point. You can agree or not, but there is a vision. And then you can adapt the service to the global demand in your matrix. And so every 2 years, I think you have to go from step 5 to step 3. Every time reevaluate the way you calibrate your offer, and every 10 years you have to go back to the land planning step. By example, the RER infrastructure in Brussels, it started in land of 90s, and we are still in 20 years later. And is the need to come to Brussels the same than 20 years ago? It's a question. So you need that this methodology is at the top of the infrastructure planning also, and the way you calibrate your infrastructure in the future. Then an important question is how you can increase the public transport market share. At the left side, you have the today situation of an imaginary countries where you have cities and you have a lot of flows between the cities. And you could never construct an efficient public transport network on such a situation. You have to make choice because you cannot, with a limited budget, satisfy all the population. So I think the first step is to improve the land planning, the way you calibrate the shops, the schools, the workplaces on your territory. That's the first step. And also promote new ways of living, of working, to decrease the number of cells where there are flows. And so if you have the situation on the right matrix, which is in fact the tomorrow situation, you can hope that it's more structured. You have more patterns in the matrix. You can better calibrate your public transport network on this matrix than on the left matrix. A second step is you can also match the mobility demand and the solution. You can put the train or the metro or the tram really where it's needed, or also promote people living near stations, and that's a two-side approach. But rail is made for high flow, not for small flow, or it costs a lot and it transports nobody. Buses is for medium flow. And then for other flows, you have new solutions, car sharing, from a public transport point of view, car sharing, carpooling, solutions that can improve the number of people using a car. Because we computed that in Wallonia, there is more than 100 billion places, kilometers made by cars, and buses, it's only 8 million. So it means that you could never reach the service that is given by the cars in a territory. And the first thing is to improve the 1.2 people by car. That's a way to do public transport, in fact, to tackle this congestion approach problems. And even if you double the number of buses, as the previous speaker said, you can never attract every people, and it's not possible. You pass from 8 to 16 billion passenger kilometers, so you cannot have all people. And so public transports have to serve the general interest, the big flows, the flows on the matrix where the value are high, and you cannot serve the particular interest. And it's also different of social transport. If you have one person, one old person that is living in a small village, you have to take it into account. But it's another point of transport. It's more social transport. It's not public transport from my point of view. Public transport is really for all. And the last slide for my presentation is that those mobility matrices can help to match the mobility demand and the client segmentation. You can do those matrices by age, by job category, by time periods, by day, by city, or by region. But some are possible, some are not possible. By example, by age, it's not possible due to privacy issues to use big data and to cross them with the sociology of the users of the data. But it's opened a door to better understand how people move depending on their category. And by example, you can create a public transport network just for the young to go to school. That costs a lot because you only have buses full at 8 o'clock and at 4 o'clock. So what do you do with your driver between 8 and 4 o'clock? So if you want to be efficient, you need to serve everybody, and also on the links I showed on the matrix. And finally, there are also advantages, which is a better client relationship. If you can interact with people that are moving with apps to inform him from delays or giving him information, or knowing that it is taking more a line on another, you can deliver a better information to your clients. And finally, it's also about intermodality, which is not a nice concept. That's only we ask the client to make efforts to go to the station, to the bus stop, but at the opposite, as we can concentrate more our capacity and our offer on structuring lines, we can offer more frequency, more speed, and so by having small lines that are going everywhere on the territory, we lose this power of attraction. So I think intermodality is really conceiving a public transport network which is more structured, and people will make an effort to catch the train, to catch the bus, if only we have frequencies, we have speed. So that's our vision of constructing a public transport network, and we try to implement it. We are now gathering the big data, and we have really encouraging results, so we hope it will be accepted by also the political world, that will have to change its view on the public transport, especially in Wallonia. So I don't know if there are questions about my presentation.
On the 10-year horizon, a bit optimistic with respect to spatial planning, because typically spatial planning is a process that takes 20, 30, 40 years. If you want to do something about all the urban housing and stuff like that.
Yeah, you can increase the number of years, but I want to say that's more a long-term process. You can do 15, 20 years, but I think it's interesting to recalibrate your vision of the land planning, even if it's 15 or 20 years, but I agree, perhaps 10 years is too small.
Yeah. So first strategy and then data analysis. Don't you think there's a loop back that you find interesting stuff after analyzing data and has consequences for your strategy?
You mean using the data to adapt the network? Yeah, that's what we do in a sense. We check the global demand on the matrix, and we see how people really moves. And then we try to adapt our network, but I showed that if it's very complex, if you have flows in every sense, you have, as a public transport company, to make choice. You cannot transport everybody everywhere. So that's what I wanted to show you. You are efficient if only the matrix is structured, if it's easy to understand the flows between the cities, and you can find all the functions you need in the cities you are living, schools, and if you need to go to school in the next cities, to go shopping in another cities, to go to the university in another cities, at the hospital in other cities, the public transport network will never be efficient, because it's too complex to deserve all the territory and all the directions. That's what I wanted to show. So we use the data also to improve or decrease the quality of the service.
Okay, I fear we have to move on to the next speaker because we are running a little bit behind schedule. But I think that Sabine Wolf from Infrabel, the data scientist at Infrabel, will address similar topics because it's more or less related problem setup.
Hey, I hope you like this presentation. This presentation was held in the Brussels Data Science Community Meetup. If you want to know more of when these meetups are taking place, just check the link below. Bye-bye.